Hello everyone, welcome to the problem session. Now today's problem comes from JEE and from paper 1 2025. Now this is a really stupid problem, belongs not in the physics but chemistry paper. All right. So it's about significant figures. So which of the following option the volume of the strip with correct significant figure? So significant figure, when you multiply things, like if you multiply A, B, C, then significant figure in here will be least among A and B. So significant figure here of V equals the lowest sig fig of A, B, or C. Okay. Because significance reflects your uncertainty, and so if you're uncertain even the first digit, then what's your problem keeping second and third and fourth digits? I mean, that just doesn't make sense. So all you have to do is which one of these is correct, and all of them, like they're more or less similar numbers. So you have this guy, its significant figure. How do I get a significant figure of that guy? How do I get a significant figure of that guy? How do I get a significant figure of that guy? All right, that's the main question. So the way to get a sig fig is actually write this damn thing in like x point y x1 dot x2 x3 whatever dot times 10 to the power some exponent m. Can be positive or negative, and this can be positive, negative. Everything is positive here. So that's the when you write a number like this is called scientific notation, and then you can tell significant digits from here. So suppose I get to x n, so this will be n sig figs. All it means is if thing was measured, then you had a x1 dot x2 x3 all the way to xn digits, plus minus uncertainty will be in the same y1 y2 all the way to yn. So you need all the way here. This is the uncertain part, okay, times 10 to the power m. So this is the digit that's uncertain. Everything else here is certain. Okay. So if you write uncertain like that, so okay, so over here you can write 1.05 times 10 to the power minus 1. So it has all three. Sig fig is 3. How about this guy? Let's do this one. Let's say order by order. So this one is 0.05. Well, this can be written 5 times 10 to the power minus 2. So this is just one sig fig. Just one digit you need. This guy is already, this is 10 to the power 0. This is already 2 sig figs. So this one is already in this form with m equal to 0. So we have sig fig. So this is the lowest. So this will be lowest will be 1. I also look at this. This is the only one that's 1. This has 2 sig figs. This one will be 1, 2, 3 sig figs. So our this should have been written 3.20 times 10 to the minus 5. 3 sig figs. This is 2 sig figs. This is 3 sig fig. So this is 1 sig fig. So the D is the answer. Answer is D. The trouble is when people write numbers like this, it's hard to tell the sig fig. You have to write a number that are in this scientific notation form, and then you can immediately tell the sig figs. So next time you come across a sig fig problem, don't memorize all the rules of the sig figs. That's just going to confuse you more. Just try to write the number this in the scientific notation, and you'll immediately know how many sig figs you need to write in that scientific notation. Okay? And they all refer to the uncertainty that you will have in your experiment. All right, so this experiment is uncertain in the last digit. So this, all of it, uncertain right here. The last digit. Sometimes you can say, okay, uncertainty will be in the last 2 digits. Sometimes you will see all the way it's like 1.5763 plus or minus 0.0025. So the uncertainty in the last 2 digits. But I tell my students to actually just round the damn thing up. So this will be round up to 3 here. So this will be 3000. Then you can say this is, if you're uncertain is already, then what the hell you're doing with this? So then you round everything. So it's going to be 1.576 plus minus 0.003. So this will be 1, 2, 3, 4 sig figs. Not like 5 sig figs. So this sig fig idea is actually trying to capture how far do you have to go in digits so that you hit the uncertain part. So like this guy, it looks like 0 should be 6.0. Maybe I can just get rid of this 0. No, you can't get rid of 0. The reason it's this written, somebody wrote it like this, it was plus or minus 0. Maybe 0.3. So that was the error bar, and this is the main value. So you got to keep the 2 sig figs here. This is already in the scientific notation, but 10 to the power is 0. That's why this thing is not written down. Okay, hope this helps. I don't like this kind of problems in the theory part. Yeah, in the lab, you really need this to indicate which part is you're certain, like you're certain about this part. You're not certain about this part at all in here. And your uncertainty in this part is that last digit over here. Round it up. Okay. Or at most, if you say, okay, I want to keep it up, I'm going to keep these 2. When I'm write this uncertainty, I'm going to write maybe up to 2 digits. That's it. But the more practice is to round it up to 1 digit. Now, if you had, say, instead of this, suppose you had 0.00224. What should you do? You drop it, then it becomes 2. And you think this is actually could have been 5 would have been 6. Then dropping it doesn't really convey the full information. So in such cases, you just keep the whole 2-digit. But if dropping, rounding up uh, does not actually lose the information significantly, then you just go ahead and drop it and keep only 1 digit, the last digit that's uncertain. Okay, hope this little discussion clarified some of the things you might have seen in your labs. I'll see you in the next video. Bye.